Welcome to lesson 6 in chapter 3. Um, we are going to be identifying possible rational solutions in functions. So really just an extension of what we did last lesson. Um, I mean, we were finding zeros, now we're finding solutions. It's kind of the same thing, but just some different methods to get that done. So here you have the equation, or I'm sorry, the function given. It appears like 4 is a 0. Same without substituting. So like without substituting 4 in and seeing if it works. Um, what other way can you use? So what we're going to use here is what's called the rational root theorem. Um, if you look at the function, you use the constant, which is 4. Doesn't matter that's negative because you're using positive and negative of both. And then the leading coefficient is 8. You find all the factors of the constant and all the factors of the leading coefficient of 8. The rational root theorem states that the possible rational roots are the combination of the constant, factors of the constant divided by factors of the leading coefficient. So you take all those possibilities. So in this case, all the orange numbers divided by all the blue numbers. Those are the possible rational roots. Among the possible rational roots, 4 over 1 and 8 over 2, they both reduce to 4. So it is possible that the 4 that you're seeing there crossing through the graph would be a rational root. Obviously, you can confirm that by doing substituting it in or doing synthetic division, but you can at least narrow it down without doing any of that to this list of numbers. Okay, so let's check out the try it question. So now we're going to list out all the possible rational roots for each equation. So you're really just looking at the constant, all the factors of that number, and then all the factors of the leading coefficient. When I give my list, I'm not going to have repeats like the book just had. So for instance, 4 over 1 and 8 over 2, I'm not writing twice. That's just 4. Anyway, so why don't you pause it here, give these a try to come up with your list, and then check back for the answer. Part A, my constant was 8, so the factors are plus or minus 1, 2, 4, and 8. The leading coefficient was 4, so my factors are plus or minus 1, 2, and 4. The possible rational roots, PRR, are just all of these divided by all of these. So I just do it in order. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. Then 1 divided by 2 is 1/2. 2 divided by 2 is 1, already have it. 4 divided by 2 is 2, already have it. 8 divided by 2 is 4, and I already have that. Now I'm going to just divide all those by 4. So 1 divided by 4 is 1/4. 2 divided by 4 is 1/2, already have that. 4 divided by 4 is 1, already have that. And 8 divided by 4 is 2, and already have that. So your possible rational roots are plus or minus 1, 2, 4, 8, 1/2, and 1/4. So again, this is a list of the possible rational roots. So if you see it crossing, if you to use this this theorem productively, you've come up with a list of the roots that it could be. So if you're seeing on a graph that it's crossing over, like let's say 3, well, guess what? It's not actually 3. It just might be zoomed out a little bit, but it's probably an irrational number, right? Because it's not part of the possible rational roots. If you were to graph this function and see it crossing at 3, for instance. Down here, basically the same thing. 45 has factors of 1, 45, 3, 15, 5, and 9. 7 has factors of 1 and 7. So the first 6 are just my factors of 45 divided by 1, so the factors of 45. Then I take all those factors of 45 and divide them all by 7. So 1/7, 45 sevenths, 3 sevenths, 15 sevenths, 5 sevenths, and 9 sevenths. So all those 12, well, I guess it's actually 24 because you have positive and negative possible rational roots for that function. All right, let's look at example 2.